In this video, we're going to cover fields again, fields or instance variables again. We introduced those in topic 1, but we're going to cover them in a little bit more detail. And then we're going to talk about constructors. So constructors are new for topic 2. And constructors and fields are related because when we use a constructor to create a new object, it sets the value of our fields. That's what constructors are used for. So you can, if you remember from topic 1, and I'm going to use the words fields or instance variables interchangeably. They mean the same thing. Some people will call them fields, some people will call them instance variables. The study guide calls them fields a lot. I generally call them instance variables. So instance variables are small amounts of memory inside an object that can be used to store data. And you'll remember from topic 1, our instance variables are declared at the top of our class. So these are going to store information for the object that we create from this class. So the types we talked about last week were strings, ints, doubles and booleans. So you should all know what a string does, an int does, a double does and a boolean does. So these instance variables are going to store data about the object that we create from this class. So you can see this class is called student. So I have created an instance variable for the student's name, their email address, their age, their grade point average. It's a boolean for is enrolled, so true or false, whether they're enrolled or not, a string for their degree and a string for their address. And I could write as many instance variables as I need for this student. So we always declare our instance variables private, we always give them a data type, and we always give them a name. You're always going to follow that format. They must be private, you always have to give them a data type, and you give them a name. So instance variables are available to the whole class. So these instance variables, I can access them anywhere from the start of the class here, after this parenthesis here, all the way to the end of this class. They're available to the whole class. We call that the scope of the instance variable. The memory for these instance variables is created when the object is created, and this memory will persist until the object is deleted. Now, instance variables should always be declared private. Java won't complain if we declare them public, so I could say this is public, but I will complain if you do this, and you should never ever do this. This is very poor programming, and we'll talk about why shortly. You should always declare them as private. What that means is they're not accessible outside the class. Anything that you declare private is only available to the class it's declared in. So, and the same goes for methods down here. If I declare a method private, it is only accessible to the class it's declared in. If I declare it public, any other class can access it. Instance variables should always be private, and we'll talk more about that shortly. So instance variables, you can see on my slide, they require a data type. You can see all of my variables have a data type. That's going to specify what type of data that instance variable can store. We can declare them with a value if required. We generally don't, but see this age, I could say it's equal to 80 when I declare it. We generally don't though. That's what a constructor is for, and we'll talk about that in a minute. And once again, we always name them lower camel case. Remember, lower camel case means the first letter of the first word is lowercase, following letters are uppercase. So lowercase email, uppercase address, lowercase grade, uppercase point, uppercase average. Remember, classes are upper camel case. So classes, if we had a class called grade point average, we would have the G here uppercase, and we never have spaces in our names either or underscores. So that's instance variables. Okay, they're places for us to store data for the object that we'll create from this class. So you can see I said that we could declare them with a data type. We generally don't. That's where constructors come in. So constructors are very special in Java. Constructors set up the object when we create the object. We call this process initialization. So you remember from last week in topic 1, when I had BlueJ open, let me compile this. Remember, if it's got grey lines on, we need to compile. Look, when I create this student, remember, to create an object, we right-click on it and we select one of these new options. Notice I have 3 of them. These are constructors. Let's have a look at our code. So if I bring this over here and I bring up my code next to it, look, public student, no parameters. Public student, 2 parameters. Public student, 3 parameters. So if I right click on student, new student, no parameters, that's this one. New student with a name and an age, that's this one. New student, name, age, email address and degree. Name, age, email address and degree. So when I create an object, I'm calling its constructor. So if I go here, new student, remember I give the name, the object a name, and I'm going to call this one some student. Remember, the name for our objects is always lower camel case. I've just called this constructor here. If I select the second one, it wants a name and an age. Remember, a string we always surround by double quotes, so I'm going to say Alex, and age, I'm 44. Okay. So I've got 2 objects that I've created. I used the first constructor for the first object, the second constructor for the second object. Now remember, the first constructor took no parameters. So remember, if we want to have a look at the state of the object, which are the values in these instance variables, if I look at the first one and inspect it to look at the state, null, null, 0, 0.0, false, null, null. Look at the second one. Inspect it. Name, Alex, age, 44. So remember from topic 1, each object has its own state. When I take that class and I create an object, each class gets its own copy of the instance variable. So when I created this first object, all of these spaces in memory were created just for the first object. When I created the second object, all of these spaces in memory were created just for the second object. So now let's have a look at the constructors. The first constructor does nothing. There's no code there. It doesn't do anything. That's why none of my instance variables are set. But let's have a look at the second one. The second one took a name and an age. And then I've said this dot name equals name and this dot age equals age. So the keyword this refers to the instance variable. So this dot name is referring to this instance variable name. This dot age is referring to this instance variable age. Name without the this is the parameter name. Age without the this is the parameter age. So what I'm saying is, when I call that constructor here and I pass it a name and an age, it gets passed as parameters to the constructor. Then it gets the name and it assigns its value to the name here in the instance variable, this dot name. And it takes the age I passed and passes it as a parameter to this constructor, and it assigns it to this dot age, which is here. So what I've done when I've created the object is I've given it its initial values. Likewise, if I created a third object and I passed it these 4 parameters, it would set the name, the age, the email address and the degree. So I've written 3 constructors for this. object. So I have three ways of creating a student. I can create a student with none of the instance variables set. I can create a student and I can set the name and the age, but none of the other instance variables. Or I can create a new student and I can set all four of these instance variables. I could also do something in my constructor. Let's just say I wanted to set is enrolled. I could go is enrolled equals false. So I can also set them to values that I want that aren't passed as parameters. So you can see that's what a constructor does. Constructors are named. They always have the same name as the class. So my class is called student. The constructor has to be called student. See, they're all called student. A constructor also does not have a return type. Remember, methods have a return type. Constructors do not. So if you see something in a class that has the same name as the class and no return type, it's a constructor, but it must have the same name as the class and it must have no return type. And then we have the constructor parameters. Now you can have as many constructors in a class as you want. You can have as many as you want. We call this constructor overloading. But they must have a different number or different type of parameters. So here I could get rid of this and I could have this constructor takes in a name and a string and an integer, and this one takes two strings. That's fine. They have the same number of parameters, but they're not the same type. But what I could not do is have constructors with the same number and same type. So if this one here takes the string name and this one here took the string degree, Java will complain about this. You can see it's underlined with red. This one takes a string and this one takes a string. This is not allowed. If we're going to have multiple constructors, they either need to have a different number or a different type of parameters. If this one took an integer and this one took a string, that's fine. But I can't have two constructors both that just take one string. So just to sum up, constructors are used to initialize our instance variables when we create an object. Constructors always have the same name as the class. Constructors have no return type, and constructors can have parameters. Now, one final thing to note. If you do not create a constructor, Java will create one for you. Let's just say I was to delete these constructors. Now I compile my code. So look, I have not coded a constructor. If I right click on it, look, new student. So if I do not create a constructor in a class, Java will create one for me, but it will just create a default one. The constructor Java would create would look like this. It would just be a default constructor that does not initialize anything. So if I don't create one, one is created for me. And it has to create one for me because I can't create an object without a constructor. I must have a constructor to create an object. So if I don't create a constructor, Java will create one for me. If I do create one, it won't create one. So if I create just one constructor, this one here, that takes a name, actually I better also comment this out here. And now I compile my code. Then I have only this one constructor that takes the name. So Java only creates that default constructor. We call it a default constructor because it doesn't do anything. It only creates that constructor if you don't create one yourself. As soon as you create a constructor, then you're responsible for managing your own constructors. If you don't create a constructor yourself, Java will create a default one for you.